What's your favorite picture of space? Maybe you think of one of those Hubble Space Telescope images of the Pillars of Creation, or the Carina Nebula, or a distant galaxy. Or maybe you have a memory sometime in the past of going outside to a dark, pristine sky and seeing all the stars overhead just with your eyes. All of these images have one thing in common. They're all static. They capture a single moment in time. They're snapshots. And while astronomers can learn a lot from images like these, lots of things in the universe are moving, they're dynamic, they're ever-changing. And so what we would really like to have is a movie. This is why a team of international scientists are building the Large Synoptic Survey Telescope, or LSST. When this telescope is completed, it's going to have a main mirror that's 8.5 meters across. That's like 27 feet. It's going to have the largest camera ever built. The camera itself will be the size of a small car. And inside that camera will be a 3.2 gigapixel detector. That's like hundreds of iPhones. And it's going to take an area of the sky with each image that's larger than the size of the full moon. When this telescope comes online in 2022, it will embark on a 10-year survey of the entire southern sky. And over the course of a decade, it will stitch together the highest resolution movie of the night sky ever made. And not only that, it's going to be in full color because we have 6 different color filters. LSST is poised to revolutionize pretty much every area of astrophysics. Everything from finding a moving asteroid in our own solar system to discovering distant supernovae, exploding stars in faraway galaxies. But we recognize that in order to do this, that the software is at least as important as the science. My team at the University of Washington is writing software to process the images that come off of the LSST in real time. We're talking 15 terabytes of data every night. That's more than you can fit on your computer's hard drive. So every single night, within 60 seconds of the shutter closing on any given image, we have to compare the new image to the old image and see if anything has changed. The changes we detect will be sent into a public alert stream that anybody can then filter and search to find objects of interest. All of our work is public and open so that other scientists and people like you can see and use the tools that we're building. So, in 2022, the movie begins. I am incredibly excited to share the ever-changing dynamic cosmos with you, because we're going to find new kinds of variable sources and moving things that we didn't even know to look for. Coming soon to a night sky near you, everyone's new favorite space picture, LSST. It's actually a movie.